Hi everyone, I'm Sanchit Pathak, part of the customer success team here at Crusoe. Welcome back to the AI Lab. Today, we are going to look at how to navigate NVIDIA's Blackwell generation to find the right architecture for your specific AI workloads, and how we leverage Kubernetes to manage these advanced GPU clusters. If you're into technical deep dives like this, go ahead and like and subscribe to catch future videos. Selecting the right infrastructure starts with your model size and cluster requirements. For many organizations, building or fine-tuning small to medium models, typically those under 500 billion parameters, the NVIDIA HGX B200 on Crusoe Cloud is an ideal high ROI choice. It provides the familiar 8 GPU form factor that many builders already use. So let's say we have two B200 nodes here. Each with 8 GPUs, utilizing InfiniBand for ultra-fast inter-node communication. The HGX B200 shines in deployments under 4000 GPUs where simplicity and standard air cooling are priorities. It's a powerful workhorse for teams looking to maintain their current workflows while gaining a significant step change in performance over the previous generations. As models scale into trillions of parameters, this infrastructure needs to evolve. This is where NVIDIA's GB200 Grace Blackwell superchip comes into play. The NVIDIA GB200 NVL72 on Crusoe Cloud is specifically architected for massive foundation models and reasoning-based tasks. Instead of an 8 GPU server, it uses a rack-scale design. So let's consider this as a single rack, where the 5th generation NVIDIA NVLink spans the entire system. This allows up to 72 Blackwell GPUs to behave as a single unified super GPU with a staggering 1800 gigabits per second of inter-GPU bandwidth. We have node 1 to node 18 within the rack. Each node has 4 GPUs, making the total to be 72 for the rack. This unified memory architecture is a game changer for trillion parameter models as it shatters the PCIe and networking bottlenecks often found in legacy architectures. By bringing the GPUs and NVIDIA Grace CPUs together in a coherent pool, data-intensive tasks like distributed inference can run with unprecedented efficiency. So, how do we manage these different Blackwell systems in production? That's where Kubernetes comes in. On a standard HGX B200 cluster, we use the NVIDIA GPU operator to expose the hardware as standard resources. But for GB200's rack-scale fabric, Kubernetes needs to be much smarter. It has to identify which GPUs across different nodes are part of the same high-speed NVLink domain. To manage this, we use ComputeDomains enabled by the Dynamic Resource Allocation driver, also called as DRA. Think of compute domain as a logical boundary that ensures your workload only starts when the entire high-speed fabric is ready. Let's consider you have an application with requirement for 3 replicas. Behind the scenes, your application creates a resource claim. Each replica will have a resource claim within the system. This triggers the system to activate the required number of nodes within the fabric to be part of the compute domain. and it plumbs those high-speed multi-node connections automatically, and then releases them back into the pool once the job finishes, allowing for efficient incremental scaling. At Crusoe, we provide vertically integrated platform including high-density, liquid cooling, and carbon-free energy required to run these Blackwell systems at their peak. Whether you're scaling a massive foundation model or optimizing a specialized enterprise application, we operate as an AI factory. We handle the engineering and power complexities so you have the purpose-built infrastructure to focus on what matters. If you want to see these performance gains firsthand, check out the links in the description. Thanks for watching the AI Lab, and we'll see you next time.